We're going to work on adding and subtracting negative and positive fractions. So your essential question for the day is, how do I add and subtract negative and positive fractions? We are putting them both on one set of notes because subtraction now, because of the integer rules, we change all subtraction over to addition by additive inverse. So in actuality, they are the same thing. We are going to use one example, so make sure to write that on the right side. So your example is 3/8. We're going to subtract from that a negative 5/12. Now those parentheses, they are just to simply separate the two negatives apart. Step number 1. If the problem is subtraction, we're going to change it over to its additive inverse. Additive inverse can also be stated as adding the opposite, or cross a line, change the sign. We need to make sure to change the subtraction sign and the very next sign. We never change the sign of the first number. So your example is 3/8 minus 5/12. And use your red pencil. And we're going to cross a line, change the sign, or additive inverse. Now that we've done that, let's go on to step 2. Step 2, we're actually going to break up into 3 parts. The reason being is there are several ways to do this. So we're going to start with finding the least common multiple for your denominators, because we need common denominators in order to add and subtract. So we're going to rewrite each fraction as an equivalent fraction that have denominators that are the same. So we're going to break up to A, B, and C. A, we're going to start with list. We're going to list the multiples of the denominators, and our denominators are 8 and 12. So we use 8 and 12. And we're going to list them. So 1 times 8 is 8. 1 times 12 is 12. Now 2 times 8 is 16. 2 times 12 is 24. 3 times 8 is 24. And 3 times 12 is 36. 4 times 8 is 32. And 4 times 12 is 48. Now we can keep going on to 5, 6, 7, 8. But we have found a common multiple. And it's the first one that shows up. So what we're going to do is we're going to take your red color pencil and we're going to highlight that one so we know which one we're going to use. So we're going to use 24. 24 is 2 times 12 and 3 times 8 to get 24. Those are important to know because we are actually going to use those to change your numerators. When you change your denominator, you have to change your numerator and your denominator by the same amount. So we're actually multiplying 3 by 3 and 8 by 3. When doing this, it doesn't change the problem or doesn't change the fraction because you're actually multiplying your fraction times 3 over 3, which is the same as 1. So 2 times 24 and 2 times 12 and 3 times 8. So we're going to multiply 3, your numerator, times 3, the same we did with the 8 to get 24. So 3 times 3 is 9. We also have to do the same thing, go from 12 to 24. So 12 times 2 is 24, so 2 times 5, or 5 times 2, is going to be 10. So we have changed our numerators and our denominators by the same value, which is, for the first fraction, 3 over 3, and by the second fraction is 2 over 2, both equaling 1. So we haven't changed the amount or the value of the number, we just changed how it looks. So we'll rewrite them with the new fractions. So we have 9/24ths, and because we did additive inverse, now we're just adding a positive, and so it's 10/24ths. Those are our new fractions. So that is one way to find your least common multiple to use as a denominator, or to find your common denominator. There is a second way, and what I want you to do is split your page up so it kind of looks like a T-chart to give you your second one. So A was called list. B is going to be called prime factorization. Now, prime factorization, what we do is we use what's called a factor tree. So prime factorization with factor tree. So we'll have 8 and 12. We'll do two separate trees, so we'll start with 8. We are looking for prime numbers that we use as factors to get 8. So what are two factors we can use to get 8? Well, there's 1 times 8 and 2 times 4. 2 is a prime number, so that stays, but 4 is not. So what we need to do is we need to do prime factorization again on 4. So what are two numbers multiplied together to give you 4? Well, 1 and 4, obviously, and 2 and 2. So the prime factors of 8 are 2, 2, and 2. That's 2 times 2 times 2. So now let's do the same thing to 12. So numbers that can be multiplied together. It can be 1 and 12, those are, then 2 and 6. You could even use right here 3. Doesn't really matter because in the end we're still going to end up with the same factors. So 2 is prime, 6 is not. So 6 we have to break down to 2 and 3. 2 and 3 are both prime numbers, so we can leave those. Now we have our factor trees done. What we want to do is we want to take the numbers that are common in both, and we're only going to use that once. We combine them together, and we use this as one factor. So we have 2, but we have another set of 2. So we're going to multiply the first 2 times this pair of 2's. So 2 times 2. And then what we have left over is a 2 and a 3. They don't have a pair, so you're just going to take them and bring them down. So it'll be times 2 and times 3. So notice these pair, we don't use them again. But then we have our 4 factors together to get our least common multiple. So 2 times 2 times 2 times 3 is going to equal our least common multiple. So we'll do the problem, we'll solve. 2 times 2 is 4. Then bring down the rest of the problem. 2 times 2, or 4 times 2 is 8, times 3 is 24. See how we ended up with the same number? We still end up with the same multiple as 24 and 24. Now what we do is, now that we know what the multiple is, we can change each of the fractions again. So notice we have 3/8, and it's going to equal something over 24. So we just have to figure out what that something is. Well, it shows us in the problem just above that 8 times 3 is 24. So we're going to multiply 3 times 3 to get our 9, just like we did in the first problem over in A, example A. Is multiply times 3. Again, that equals 3 over 3, which is 1, so it doesn't change the value of the problem. Now let's change the second problem, or the second fraction. So we have 5 over 12, and we're trying to get to 24. So if you look back here, we can have 3 and 4. 3 and 4 together equal 12, so we know that our factor we're going to be multiplying numerator and denominator by is 2. So 12 times 2 equals 24. And 5 times 2 equals 10. So in both scenarios, whether we use A or B, we still end up with 9 24ths and 10 24ths, whichever one we use. Now, you could have probably used another factor or another multiple at some point, like 48. We want to use the least common one. It makes it easier. Now let's go on to C. And now C does not use the least common, which is why I stated that, is eventually you can use 48 or any other one that comes in common, but it's just easier because then you don't have to simplify later as much. But if you ever struggle, this is the way I want you to do it, is C. So we're going to use the denominator of the other fraction to find a common denominator. So we're going to take the denominator of the second fraction and change 3/8, and then we're going to take the denominator of the first fraction and change 5/12. So we have our example. Remember, it was in parentheses. It's actually positive of 5/12. Now take your red pencil. What I want you to do is I want you to circle and draw arrows to both numerator and denominator. That means we're going to use 8 to change 5 and 12. That will give you your second fraction. So we use the denominator of the first one to change the second fraction. So 8 times 12 is 96, and 8 times 5 is 40. Now what we're going to do is we're going to go backwards. Now it doesn't matter which you do first, whether you change the first fraction first or the second fraction first. It really doesn't matter. But we're going to take 12, multiply times 8, and then 12 times 3, and that will change your first fraction. So 12 times 8 and then 12 times 3 is 36. So now we've changed it so we have common denominators. Now we can move on to step 3, which is add numerators keep denominators. Which I will show you how to do that with both 2a and b, and then separately I'll show you how to do that with c. So 2a and b ended up with the same two fractions, so 9 plus 10 is 19, and then keep your denominator, which was 24. So it's 19 over 24. Or if you did it using method C, you're going to add your numerators. That's 36. Oops, let me move the page up. Hold on 1 second. 36 over 96 plus 40 over 96. And again, we're going to follow the same thing, so add numerators, keep denominators. So 36 plus 40 is 76, and then keep the denominator, which is 96. Last step. And this should always be your last step doing any fraction problems, is you should always write in simplest form. So simplify. We'll start with C, which is 76 over 96. Because they both have 6 in it, you're going to be able to divide by 2. But always use 2, 3, or 5. I don't know why I put 1 down. But you can use 1 if you want to, but it gives you the same fraction. But divide both by 2, so 76 divided by 2 is 38. And then also 96 divided by 2 is 48. Again, we end up with both numerator and denominator are even numbers, so we can divide by 2 again. Oops. Should be 38, not 36. So bring down 18. So 2 goes into 18 9 times. Comes out evenly. So your numerator is 19. And then we take 48 and divide by 2. 2 goes into 8 4 times. So we're going to end up with 24 again. So as you can see, we end up with the same answer whether we do it using A and B, 2A, 2B, or 2C. No matter how we do it, we still end up with the same answer. It just depends on which one you like. So we end up with 19/24.